Hello everyone, welcome to our webinar on Streamlining DevOps Security with Fast and Secure Code Signing. Thank you everyone for joining in. I hope you're all doing great. My name is Surbhi Singh. I'm the Senior Marketing Consultant with Encryption Consulting. We also have our speaker, Riley Dickens, Cybersecurity Consultant at Encryption Consulting. Just want to give you a quick overview of Encryption Consulting. Encryption Consulting is an established market leader in data protection consulting. Over 100 Fortune 500 companies and over 20 Fortune 100 companies have sought our help in protecting sensitive company data and solving complex problems. Through our product and professional services, you can strengthen your ability to protect cryptographic keys, digital certificates, software code, and more. Please remember to share your questions in the Q&A bar below. And now I will hand it over to Riley.
Thank you, Serbi. I appreciate the introduction. Hello, everyone, and thank you all for joining in today. My name is Riley Dickens, and I'm a consultant at Encryption Consulting. My main focus has been on our code signing platform, CodeSign Secure, as the lead developer for the past 5 years. I've also had a hand in our integration of HSMs at client locations, and I have a hand in the advisory of encryption strategies and services that our clients may need. Now, without any further ado, let's see what we'll be covering in today's webinar. First, we'll be discussing supply chain attacks and understand their potential impact on the organization and the damage that it causes. Next, we'll explore how to prevent attacks using code signing with DevOps. We'll see how code signing within DevOps can significantly enhance our security against such attacks. Following that, we'll identify any weak links in code signing with DevOps strategy, as it is important to recognize potential vulnerabilities and the impact of insecure strategies. We'll then introduce Encryption Consulting's CodeSign Secure, a comprehensive solution designed to simplify the integration of code signing within a DevOps environment. CodeSign Secure makes it easier and more efficient to implement strong security practices. Finally, we'll discuss future trends and requirements. We'll look at upcoming trends and the future requirements needed to stay ahead of potential threats and ensure that our systems remain secure. Now let's get started with our first topic on supply chain attacks. To kick things off, let's start with a quick questionnaire. I'm going to give you a few statistics about a significant supply chain attack that happened recently, and let's see if you can guess which attack this was. This attack involved a file transfer software developed by Progress Software and exposed a critical SQL injection vulnerability in their supply chain. It was discovered in May 2023 and was exploited by a notorious ransomware group known as CLOP, or CL0P. This attack has been referred to as the biggest supply chain cyber attack of 2023 due to its extensive impact on multiple organizations and sectors. Now, can anyone guess what attack this was? It's the MOVEit attack of 2023. Supply chain attacks, like the MOVEit attack, have become increasingly common and sophisticated. These attacks target the weakest links in an organization's supply chain, which can include software, hardware, or even services. By compromising a trusted component, attackers can infiltrate larger networks with relative ease. Now let's explore more about the MOVEit attack of 2023 and discuss its execution, impact, and financial aspects in detail. In May 2023, Progress Software's MOVEit file transfer software faced a major security issue. A critical SQL injection vulnerability, known as CVE 2023-34362, was exploited by the CLOP ransomware group, leading to a significant supply chain cyber attack. The attack happened in several stages. First, cybercriminals discovered a severe SQL injection flaw in MOVEit, which allowed them to manipulate SQL queries and access the database. This vulnerability was rated a 9.8 out of 10 in severity by Progress Software. Next, The Klopp group quickly exploited this flaw, gaining unauthorized access to sensitive data like personal information, financial details, and social security numbers stored in MOVEit databases. Following the discovery, Progress Software publicly disclosed the vulnerability and released a patch to fix it. However, not all organizations updated their systems immediately. The Klopp group took advantage of this delay, targeting more organizations including banks, hospitals, hotels, and energy companies. The victims were pressured to pay ransom to prevent their data from being leaked online. Several high-profile organizations were affected, including Maximus, WellTalk, Delta Dental, the Louisiana office, and Allegert. Millions of individuals were impacted, making this one of the most severe cyber incidents of the year. Now let's examine the broader impact of the MOVEit attack on different regions and sectors. The MOVEit attack had a widespread impact, affecting numerous organizations across various sectors and regions. The Klopp ransomware group used the vulnerability to infiltrate hundreds of companies that relied on MOVEit for secure file transfers. Here's a detailed breakdown of the impact by region. In North America, the attack hit high-profile organizations like the University of Rochester, Nova Scotia Health Authority, and Puget Sound Energy, causing significant operational disruptions and financial losses. Europe was also heavily impacted. Institutions such as the BBC, British Airways, Boots, and Ofcom experienced major breaches, disrupting services and exposing millions of individuals' data. Globally, regions like New Zealand and Australia were not spared. Key organizations, including the Ministry of Health, various universities, Zealous, and Shell, were compromised. The most affected sectors were education, with 39.1%, health, with 20.1%, and financial and professional services, with 13.3%. This attack illustrates the global scale and diverse nature of the impact, affecting not only the organizations using MOVEit, but also their clients and stakeholders. It highlights the interconnectedness of today's digital ecosystem. To grasp the full magnitude of this attack, let's now examine its financial repercussions on the affected organizations. Financial fallout from the MOVEit supply chain attack was extensive. Costs included direct financial losses, remediation expenses, legal fees, and long-term impacts on operations and reputation. To illustrate the severity, the U.S. State Department offered a $10 million bounty for information on the Klopp ransom group. This highlights the urgency of addressing such threats. While it's hard to pinpoint the exact cost of the MOVEit incident, we can estimate its impact. The Klopp group reportedly earned around $100 million from their campaign, showing how profitable these attacks can be for criminals. Overall, the estimated total cost of the MOVEit hacks is around $9.9 billion. This includes breach response, system restoration, compensation for affected individuals, and the broader economic impact on organizations. These figures underscore the importance of securing our software supply chains. The MOVEit attack has been referred to as the biggest of 2023 by several cybersecurity experts due to its widespread impact and the number of affected organizations. To prevent such devastating consequences, robust security measures are crucial. One effective strategy is code signing with DevOps, which ensures the integrity and authenticity of the code being deployed. Let's now explore how to prevent such attacks using code signing and DevOps. Supply chain attacks have surged by over 430% in the past year alone, according to a recent study by Symantec. These attacks exploit vulnerabilities in widely used software, affecting numerous organizations. By incorporating code signing in DevOps, we can prevent these risks significantly. This section will show how code signing with DevOps can help prevent such attacks. Code signing is a crucial process that involves digitally signing software to ensure its integrity and authenticity. By integrating code signing into our DevOps workflows, we can create a more secure and efficient software building approach. According to the State of DevOps 2023 report by Puppet, 58% of organizations have integrated code signing into their DevOps workflows. This ensures that the code being deployed is verified and secure, preventing unauthorized or malicious code from being executed. Automation plays a key role here, as it ensures all code changes are signed and validated before deployment. Additionally, a 2023 survey by GitLab found that about 42% of DevOps teams use unified tool chains that incorporate features like code signing. These tool chains streamline the development process by integrating various tools and practices, including security measures. This integration allows for seamless collaboration and automation, reducing complexity and manual effort. Recent reports indicate that 49% of organizations are adopting automated code signing solutions to manage code signing keys and certificates, reducing the risk of human error. However, 55% of organizations face challenges in managing code signing keys and certificates within DevOps pipelines, according to a 2023 study from Symantec. These challenges include key management, certificate rotation, and securing the signing process. Effective key management is essential to maintaining the security of the code signing process. As Malay Nayak, an agile coach from New Zealand, aptly puts it, integrating security practices such as code signing into every stage of the DevOps lifecycle ensures that security is a continuous and integral part of the development process, rather than an afterthought. With these insights, we can appreciate the importance of code signing in enhancing the security and efficiency of DevOps processes. Next, let's look at how code signing with DevOps can resolve these attacks. Code signing is a vital part of a secure and efficient DevOps pipeline. It ensures the integrity and authenticity of your code while streamlining the deployment process. Let's break down how combining code signing with DevOps addresses key challenges. First, detection and prevention. Automated code signing digitally signs software code before it is released, catching potential issues early. This ensures that only signed, verified code gets deployed, reducing the risk of vulnerabilities. Regular vulnerability scanning within the DevOps pipeline also helps identify and mitigate risks early in the development process. Next is strengthened tracking. Origin verification ensures only trusted code is deployed by verifying the code's origin and build history. This strengthens overall security and trustworthiness. Additionally, auditing and reporting maintain a record of which version of the code was signed, by whom, and when, aiding in tracking and addressing any security issues. For policy and access control, implementing granular access controls restricts access to the pipeline and the signing process. Role-based access control, or RBAC, ensures only authorized personnel can make changes, minimizing the risk of unauthorized modifications. Robust access control and code signing policies also promote user confidence, increasing trust in the product. Finally, we have standardization and consistency. Automating the code signing process reduces human error, ensuring that every piece of code going into production is vetted and verified. Reproducible builds confirm that the code hasn't been altered since it was signed, adding an extra layer of security. Integrating code signing into the DevOps pipeline offers strong protection against supply chain attacks. It enhances the security of the software development lifecycle and streamlines deployment processes, ensuring that only trusted and verified code is released. Now let's delve into the potential risks of using code signing with DevOps strategy. We will explore the common weak links in the code signing with DevOps process in this section and learn how they can impact your digital security. While code signing greatly enhances software security and integrity, it also has potential risks. Understanding these risks is crucial for implementing effective prevention strategies in DevOps environments. First is key compromise. If signing keys are compromised, attackers can forge signatures and inject malicious code into signed artifacts. This can lead to serious security incidents, as seen in the DigiNotar breach, where compromised keys allowed attackers to issue fraudulent certificates, causing a major security crisis. Next, expired certificates. Using expired or revoked certificates can pose significant risks. Signed software with expired certificates may be rejected, causing operational downtime and a loss of trust. It's essential to monitor and renew certificates before they expire, ideally automating this process to avoid human error and ensure continuous compliance. Performance overhead. The process of signing and verifying code can slow down CI/CD pipelines, affecting productivity and release timelines. Balancing security with performance efficiency is key. Efficient cryptographic algorithms and client-side integration can help mitigate this issue without compromising security. Lastly, is insufficient policies. Without strict policies, unsigned or improperly signed code can slip through the deployment pipeline. It is crucial to outline what needs to be signed, establish certificate management procedures, and define revocation protocols. Clear guidelines and training for development teams can significantly reduce errors and enhance overall security. Recognizing and addressing these weak links can greatly improve your code signing practices. By being proactive and implementing comprehensive security measures, organizations can fortify their DevOps processes against potential threats. Now let's move on to understanding the broader impact of insecure code signing in DevOps environments. Insecure code signing can undermine the security and integrity of software in DevOps environments. Understanding the potential impacts of insecure practices will help in reducing risks and protecting the software supply chain. Let's explore some key consequences of insecure code signing. First, there's the risk of unauthorized code execution. Compromised or misused signing keys can allow malicious code to be signed and executed as legitimate software. For instance, the Stuxnet attack involved malicious code signed with stolen certificates, leading to severe security breaches. This highlights the need to secure signing keys and ensure only authorized personnel have access to them. Next is a damaged reputation. Users and stakeholders lose trust in software if they suspect tampering or if there is a history of compromise. For example, Adobe faced significant reputational damage in 2012 due to compromised code signing certificates. Ensuring robust security practices and promptly addressing any breaches can protect your organization's reputation and maintain user trust. Financial losses are another major consequence. Insecure code signing practices can lead to data breaches, legal fees, and remediation costs. According to an IBM report, the average cost of a data breach in 2023 was $4.5 million. These financial implications underscore the importance of securing code signing processes to avoid costly breaches and potential loss of sensitive data. Finally, there's the issue of regulatory noncompliance. Failure to securely manage code signing can lead to noncompliance with industry regulations and standards, resulting in hefty fines. Under the GDPR, fines can be up to 20 million euros or 4% of annual global turnover, whichever is higher. Compliance with standards such as ISO or IEC 27001 and NIST guidelines helps organizations stay ahead in their security practices. Understanding these impacts emphasizes the importance of secure code signing practices in DevOps. By addressing these risks, organizations can protect their software supply chains and maintain the integrity and trustworthiness of their code. Now, let's shift our focus to a solution specifically designed to tackle the challenges of code signing in DevOps effectively: Encryption Consulting's CodeSign Secure. CodeSign Secure offers robust features that integrate seamlessly with DevOps practices, enhancing security to prevent supply chain attacks. First is our robust key and certificate management. CodeSign Secure uses hardware security modules, or HSMs, and secure key management systems to protect signing keys. This prevents key compromise and ensures expired certificates don't jeopardize software integrity. HSMs generate, store, and manage keys in a highly secure environment, making unauthorized access extremely difficult. Next is our automated signing and reproducible builds. CodeSign Secure integrates with CI/CD pipelines, automating the code signing process. This ensures that builds are reproducible, meaning any given source code will generate the same signed binary, preventing tampering and enhancing supply chain integrity. Consistent security standards are maintained across all builds and deployments. Next is our continuous monitoring and auditing. CodeSign Secure continuously monitors signed code for anomalies and unauthorized changes. Detailed audit logs of all signing activities enhance the detection of potential security breaches and ensures compliance with security policies. Proactive monitoring allows for immediate identification and remediation of issues, minimizing the risk of compromised code entering production. Lastly is our enhanced policy enforcement. CodeSign Secure enforces strict code signing policies within CI/CD pipelines, ensuring that only signed code by authorized users is deployed. By defining and enforcing policies on who can sign code and what can be signed, organizations can prevent unauthorized code from being deployed. Integrating these features, CodeSign Secure provides a comprehensive solution to code signing challenges within DevOps, enhancing the security and efficiency of your deployment processes. This tool simplifies code signing management and ensures your software supply chain is robustly protected against emerging threats. Integrating code signing into DevOps processes is crucial to ensure software security and integrity. Following best practices can significantly reduce risks and enhance overall security. Let's go over some of these best practices. Starting with source code, always verify third-party and open source libraries before integrating them into your projects. This ensures that you are not inadvertently incorporating vulnerabilities into your software. You should also prevent committing secrets, such as API keys and passwords, to the source code repository. Using tools like Git Guardian can help detect and prevent such leaks. One other thing you can do is utilize SSH keys to provide developers with access to repositories securely. This adds an additional layer of security by ensuring that only authorized personnel can access the codebase. For the software supply chain, monitor code signing certificate requests to ensure that they are legitimate and authorized. You should also automate policy enforcement as per industry standards to maintain compliance and consistency across your development practices. One other thing you can do for your supply chain is to regularly rotate keys used for signing different releases across multiple DevOps teams to minimize the risk of key compromise. When it comes to provenance, sign every step in the build process to ensure that each component of your software is verified and trusted. You should also automate software security, scanning, signing, and testing to streamline these processes and reduce the risk of human error. Time-stamping code while signing can provide a verifiable history of when the code was signed, which is crucial for auditing and compliance purposes. Finally, in the deployment phase, you should ensure clients have access to the latest versions of your software to benefit from the most recent security updates and improvements. Additionally, you should verify artifacts and signatures to ensure the integrity and authenticity of the deployed software. One final step in the deployment phase is you can implement a runtime vulnerability scanner in the production environment to continuously monitor for potential threats and vulnerabilities. By following these best practices, organizations can enhance their overall security posture and ensure that their software remains secure throughout the development and deployment process. These measures are essential for building a resilient software supply chain that can withstand the evolving threat landscape. Now let's take a closer look at how code signing integrates with DevOps processes. The software supply chain has many integral pieces and components that can easily be tampered with or injected with unwanted code. Developers are embracing code signing into their pipeline to assure security against potential threats along the development and deployment process. Here's a typical workflow of a code sign with DevOps pipeline. First, the developers commit changes to the source code repository. This is the first step where code signing can be introduced to ensure that all changes are verified and trusted. This code could be written in any programming language and software, such as VS Studio or Eclipse. This code is then pushed to the repository, which acts as the central point where code changes are stored. It is crucial to ensure that only authorized and verified code enters this repository. As per industry standards, GitHub is the most preferred tool for this phase of development. The continuous integration server initiates the build pipeline, pulling the latest code from the repository. This stage should include automated code signing to verify the integrity of the code. There are many tools for this automated stage, such as Jenkins, GitLab, or CircleCI. During the build process, binaries are created and signed with a digital signature. Signing binaries ensures that the code has not been tampered with and that it is safe for deployment. The signed binaries are then verified and validated to ensure they meet all security and functional requirements. This step is crucial for dealing with any issues before the software is deployed. If any errors are detected during the signing process, they're addressed promptly to ensure that only secure, verified code moves forward. After successful verification and validation, comprehensive testing is conducted to ensure that the signed code works as intended and integrates well with other components. Once the code has passed all its tests, it is marked as ready for deployment. Organizations can maintain a high level of security and integrity throughout the software supply chain by integrating a code signing phase. This integrated approach ensures that every piece of code is accounted for and verified, minimizing the risk of vulnerabilities and unauthorized changes. Now let's discuss the future aspect of code signing with DevOps and learn about the trends and requirements. As we look towards the future, it's essential to understand the emerging trends and requirements in the realm of code signing and DevOps. The landscape of cybersecurity is constantly evolving, and staying ahead of these changes is crucial for maintaining robust security practices. Let's dive into the future trends and requirements for using code signing with DevOps. Code signing with DevOps is set to evolve significantly, with increasing automation and tighter integration. This future will see seamless use of code signing tools within CI/CD pipelines, ensuring that code is signed at various stages without interrupting workflow. First, AI Ops and ML Ops. AI Ops will use artificial intelligence to identify the root cause of problems, enhancing productivity. ML Ops, or Machine Learning Ops, will automate the deployment and monitoring of machine learning models, making operations more efficient and secure by promptly detecting and addressing anomalies. With reproducible builds, ensuring software builds are reproducible basically means that the same source code produces identical binaries, preventing tampering and enhancing transparency. This is crucial for maintaining trust in the build process. With hybrid development, organizations can combine on-premises resources with cloud-based services, creating flexibility and resilience by diversifying infrastructure. Next is containerization. Containers package software with all of its dependencies, ensuring faster app deployment and delivery. They allow for consistent environments across different development stages, making application management and deployment easier. Finally, there is the idea of a zero trust security model. Implementing zero trust principles ensures secure access controls and continuous trust verification, regardless of network location. This approach continuously validates every request, assuming threats can come from inside or outside the network. These trends highlight the direction of software development and security. Embracing these trends will help organizations maintain a robust and secure development process, keeping pace with the evolving threat landscape. Now let's see how CodeSign Secure addresses these trends. CodeSign Secure is designed to meet the evolving needs of software development and security, ensuring seamless signing throughout the development lifecycle and addressing key future trends and requirements. Let's discuss the current advancements in CodeSign Secure. First, there is flexible deployment options. CodeSign Secure supports hybrid deployment models, integrating smoothly with both on-premises and cloud infrastructures. This flexibility enhances resilience and scalability, allowing organizations to choose the best deployment strategy for their needs. With strict access control, CodeSign Secure uses SSL authentication and Azure Active Directory login to ensure that only authorized personnel can sign code, maintaining the integrity of the code signing process by preventing unauthorized access. Then there is our container signing. CodeSign Secure offers robust Docker capabilities in container signing with Kubernetes to secure containerized applications. This is essential for efficient application deployment. Now we can touch on our reproducible build and verification. CodeSign Secure enables build verification and reproducible build using tools like GitHub and Jenkins, ensuring that the same source code produces identical binaries. This will prevent tampering and enhance trust in the build process. Now let's shed some light on the upcoming features that will improve our digital security. First up, we have our advanced AI and machine learning integration. Soon, CodeSign Secure will integrate advanced AI and machine learning capabilities to proactively identify and resolve security issues, making it a more robust security solution. Next is our data-driven insights and analysis. This will provide comprehensive data analytics to offer insights into code signing practices and identify potential security gaps. This will help organizations optimize their security measures and ensure compliance with industry standards. By addressing these trends and requirements, CodeSign Secure provides a comprehensive solution for modern software development and security challenges, ensuring that your code signing processes are robust, secure, and adaptable to future needs. This concludes our presentation on streamlining DevOps with code signing. I hope you found all this information valuable and insightful. We've covered a lot today, from understanding the importance of code signing and addressing potential risks to integrating best practices, along with staying ahead of future trends. Now I'd like to open the floor to any questions you might have. Please feel free to ask your questions in the Q&A bar below.